Hello world, my name is Ian Solomon. I like it when I'm called on my alias, Gopher. I'm a level 3 networking student and I'm also a founder of an upcoming IT service provider called Rootech Incorporation. Today is going to be fun. I'm going to be talking about network port security in this video presentation. When I say network port security, I know most of you already know what it is and then it entails a lot. It's very broad, but basically I'll be taking the firewall aspect, how to manage network port security in a network environment using firewall. From the one of my studies into IT field, I've been following tutorials and then videos I watch. And then one thing I've realized that when you're watching the tutorial, or let me say a video presentation, you're supposed to stay relaxed and focused. So as of now, I urge anyone watching this video to grab a coffee or drink. It's not forced. If you can't afford it, you can just grab water, drink, and make sure you are relaxed to continue. This is an overview of what I'll be talking about in this video presentation. First of all, I'll talk about introduction. When I say introduction, I mean the broad topic, which is network port security. I'll talk about what it is and how it works. And also go ahead and talk about net filter. Net filter is an inbuilt tool which is used to protect our firewall. And then I'll also talk about services that are used in controlling net filter, which is IP tables and then firewall. I'll talk about various configuration options. Also talk about configuration files, talk about firewall zone, IP masquerading, and then port forwarding. IP masquerading and port forwarding will come at the later part of the video if there's enough time. I've limited to only 25 minutes. And after all, I'll give a live configurational demo since we know watching the job done is part of it taken in the head. One may ask, what is network port security? The first day I heard this, I thought like, is it a special way of securing our cars from going through these potholes on our roads? Because our economy is bad and that the roads are really in bad state. Or like, do they have special security features in our various ports? I mean, like harbor. Now, you all have the right to think it something that way, but when we talk about network port security here, we are relating it to the Linux environment, how to secure our ports on a network. I will explain how ports work in network. In computer communications, day in, day out, traffics are being transmitted. And then all traffics can come through one port. We have ports like, for instance, port 23, which controls internet connection. If there's an incoming or outgoing internet connection, you always by default come in through port 23. If there's another HTTP transmission at the same time, all these transmission can come through one port. Communication will be congested and then the computer will be confused. So there's a special port for it too on the same computer, and we all know by default HTTP connections come in through port 80. That's how ports are separated. For instance, in my diagram, you can see that I have 4 computers on this network, a firewall, and then a rack. This rack contains services that these users make queries to day in, day out. These services can include DNS services, DHCP, HTTP services, or even this rack can contain a file server. Realize that from our diagram, user 1 and 4 has been denied access to the diagram by the rules in our firewall. Relating it to our local ports, maybe user 1 and 4 can be considered as ships carrying weapons, and we know it's illegal to bring in bombs which are illegal into the country. So they have been denied access to the port, which is our rack. And then we realize that user 2 and 3 have been given access. If we relate these two ships, maybe they are carrying commodities that are sold day in, day out, like milk, Nescafe, which I take a lot. So we have been given access to park at this port. That's the same way network port security works in Linux. And then it's a nice feature. Every system administrator to know the port security of his system that he or she is using. Now, in Linux Red Hat Enterprise Server 7 environment, we have an inbuilt tool that is used to manage our firewall rules. This inbuilt tool is called NetFilter. When a complete graphical installation of Linux, let's say Red Hat, is done, NetFilter is an application that comes by default. You don't have to install or download it from the repository store. That's to say you have options to select this net filter in a pre-installation environment. And I will explain the mechanism that this net filter uses to work. We can just reference to the diagram. We can see that in our network, user 1 sent a traffic of red. And then we assume that in our firewall rule, we have a rule has been created that any traffic that comes having red in its header, it should be bounced back. But anyone that has green in its header should be bounced back. Now what NetFilter does is that it reads an incoming packet and then it looks into the packet header. It contains an information. And then we have a rule with this scenario that when the information contained in this header is red, it should be bounced back. So we realize that user 1 has red in its header and then it has been bounced back. Now the information here with NetFilter, we have something called reject and then drop. When a packet has been rejected, it sends an ICMP packet. That's to say, telling the sender that, oh, you have been bounced back and then you don't have access to this cell. I'm just giving an instance of an error message. And then when it's dropped, it doesn't even send any message telling you. You just get out, rejected, terminated. When I realize that user 2 has green in its header, so it will then decide to allow it. And we can see that user 4 pretended to be coming with a green information, but like in its header, it contained a red color. And then we know that our firewall in our firewall rule it has been considered in such a way that any header that has red in it shouldn't be accepted. So it has been bounced back. That's how NetFilter works in others. You can't fool it. Excuse me to say, you can't lie to it saying you are green when you have red. It will read and then decide on what rule to apply to you. NetFilter must be managed. By default in Red Hat environment, NetFilter is just like a kid when it's been installed. It doesn't know what to do. It's just sitting there. And then we have services that can be used to manage NetFilter in a Linux environment. These services are IP tables and Firewalld. I'll first of all talk about IP tables. IP tables by default is installed once the Red Hat Server Enterprise 7 is being installed. It has no rules, it's just dumb as NetFilter itself. When IP tables is being installed, part of the software package, it's just dumb, it has no rules. And then it's a rule-based system. When you don't put rules in it, it doesn't work. Now, let me talk about Firewalld, which is the main reason why I'm doing this video presentation. Firewalld by default supports IP version 4 services. It also supports IP version 6 and it supports Ethernet bridging in Linux. We know how Ethernet can be bridged in Red Hat already, I guess you know. And then it also supports Firewall Zone. Firewall Zone is just like dividing network into multiple parts. Firewall zone is a subtopic. I'll talk and elaborate more on it in this video tutorial. And also it supports the bus interface. The bus, in other words, desktop bus interface. You know, when we talk about the bus, it's just like the IPC, that means inter-process communication between applications in a system. You know, when an application is running on a dbus interface and then your net filter is being managed using Firewalld, you have the privilege. These applications have the opportunity to make a firewall change request. You know, they make a request to the firewall, for instance, saying, please, this rule shouldn't be applied because we are legal and then we are using these services. Or they can make these changes when the applications are running on a particular level. And we know Linux deals with permissions and then levels. I'll also talk about why I would decide to choose Firewalld over IP tables. Maybe someone might decide to choose IP tables based on its own reason, but I chose Firewalld because when IP table is being configured, anytime you enter a rule, it makes a restart to the firewall services. And for instance, let's imagine you are having an important transmission on your network and then you make a change to firewall rules using IP tables. You know what can happen? It will restart the communication and then your network will be lost. You have to wait for a while for it to boot up again. And Firewalld also supports dynamic zones where you can put devices into various zones based on your trust level you have for it, which IP table does not have. And then more also, which is important, Firewall is supporting the device interface, which IP tables does not. I'll now talk about configuration options. In Linux, when you are configuring Firewall, you have two major options you can configure, which are the runtime configuration option and the permanent configuration option. I hope these words are even self-explanatory, but I'll go ahead to explain. When we talk about runtime configuration, when a rule is configured in a runtime zone, it takes effect immediately. Immediately you just press the enter, the rules start working. And then it's temporary. When I mean temporary, it's like when there's a restart to the firewall services, the rule is lost. You don't have it any longer. So assuming you configure a rule in a runtime, and then, for instance, to block a particular service, you are just enjoying it. You forget, and then maybe you make a restart to your firewall service, or you shut down your PC, and then you go to come back. You realize that the rule is gone. You have to configure it again. And then talk about the permanent configuration. After the rule has been entered, it doesn't work unless there's a restart to the firewall services. And then when you are making a restart to the firewall service, you don't have to just like restart the whole machine. There's a command syntax which you can use to make a restart to the services using the systemctl. And then configurations made with a permanent option, they are made permanently. If you want to take that rule off, you have to do that manually. One will ask, how do you know if this is a permanent or runtime configuration? As I earlier on said, with a runtime, you don't add anything. You just use the default syntax you use to add a rule, which I'll do later for everyone to see to do it. And then with a permanent, after you first all type the firewall syntax, which is the default, that's to say firewall dash cmd. Before any command, any rule is added, you give space and then you put dash dash permanent. I'll use all these commands and then you see how it works. Also, there's this trick I want everyone to be aware of. You know, especially when you are working on a remote firewall, you should make use of the timeout syntax. This timeout syntax is used to specify, like, make a firewall rule run for a given time. The duration is always in seconds. For instance, if you want a rule to run for like 5 minutes, which we know is equal to 200 seconds, after the rule, before you press enter, you give space and then you use dash dash, then timeout, then you equate it to the duration, which is in seconds. You put 200 and then 200 seconds means 5 minutes. In Red Hat, configurations are stored in files. We know most of configurations are stored in files, and then these files are stored in directory. So I'll talk about configuration directory and files relating to Firewalld. First of all, I'll talk about the default configuration directory and files. When we navigate to Firewalld directory, which is under the lib directory, which is also under the usr directory, which is all under the root directory, we realize that we find some files there, and we can use the command ll, which we know we use to list content in the directory, and then we navigate to that directory and we realize that we find some files there. These files there are the default, these files and directories over there are the default firewalls directories and files. You can't modify them. It's against ethics, because modifying them will be like it can be modified but not directory, and then whenever there's a modification in the firewall rules, it makes an override to this particular directory after an upgrade in the firewall rules. Configuration, when you get to the configuration aspect, everyone will see a clear view of how everything is. And then when we talk about the etc directory, which is under root directory, which is also under the file, which also has a subdirectory called firewalld. Files stored here are the files that can be modified. Whenever a default configuration file is modified, it stores in this directory, and then in this directory, this is where Firewalld picks configuration files to load when it's put in. It doesn't check in the default, because you realize that the default ones, they are what are made by default after an installation, but when modifications are done, it stores in the firewall directory which is under etc path, and then it loads from there because they contain the latest rules being applied, and then we can view these contents by using the ll command which we use to release contents in a particular directory. As earlier one premise, I said I'll be throwing more light on firewall D zones. Now, someone may ask, what is firewall D zones? Fine, firewall D zones is basically sharing a broad network into parts so that each part can have its specific rules that bounds it. For instance, in our diagram, you can see that we have a giant network, and then our network is called routtech.incorporation. Realize that in this network, we have 10 PCs, from PC1 to PC10. And then subturate, these PCs have been divided into zones. Realize that PC1 and 2 are kept into a work zone. Let me say group for you to understand. And then PC10 and 9 have been put in a trusted zone. One may ask, why would you put these networks into zones? Firewall D basically acts on zones. We have work zone, public zone, home zone, and then a lot. There are up to 9 zones by default. I'll explain these zones one by one later. Well, for instance, PCs found in a work group are assigned to different services. On a network, they have rules that bound them, and this rule gives them access to specific services and also deny them access to specific services. And then rules that apply to zones, PCs in the work zone can be different to rules that apply to PCs in the home zone. You can make them the same, but I don't see the sense of making them the same if you want a separation. Separation means there are differences. So basically, firewall zones are like putting PCs into various groups based on the trust level you have for them. I'm talking about assignable zone features. There are a couple of features that can be assigned to a specific zone. That means when you're assigning rules to a zone, there are things you should take note of, things that you can do to a zone. For instance, when we talk about services, this includes ports and protocols that can be assigned to a particular zone. For instance, you can allow the default or drop zone to accept or be able to access services that are telnet services. So for instance, we'll say the port number for the telnet connection should be 23, and the protocol, we know telnet uses TCP protocol. And also talking about port features, this talk about a range of ports and its associated protocols that can be accessed remotely. Some ports are there, they are only UDP, and then they don't have TCP. And I'm also talking about IP masquerading. You can assign a feature to a zone whereby all internal IP version 4 addresses will be changed to a single external IP version 4 address. And this helps a lot, especially to secure your network. This hides all your internal IP addresses, and then it gives you a secure connection to the internet. Talking about port forwarding, this is a situation whereby you can decide to allow an incoming traffic, for instance, route a telnet connection through a port 80, which is like HTTP protocol. In Windows, this is not possible, but like in Linux, that's to say very hard. It is possible and it can be done. Also talking about ICMP filters, you decide to block specific internet control messaging protocol messages. These are error messages. And I'm talking about rich rules. Earlier one mentioned if there's time, which I think there's no time. And when we talk about rich rules, it's just like using an advanced feature, which is rich rule, to enhance an existing firewall rule. And then talking about interfaces, we can assign a network interface. For instance, if you have a NIC, you can decide to put that NIC in a specific zone and then bond it to a zone instead of the default zone. Also, there are predefined firewall zones. As I already said, that we have 9 of them, and then I will give a brief explanation of them one by one. First of all, we have the trusted zone, and then when an interface is placed in a trusted zone, means it is bound to allow all incoming traffics. It doesn't drop any packet. And then we'll talk about the home zone. It rejects all incoming traffics unless related to outgoing or matching the secure shell, DHCP version 6 clients, the Samba client, and etc. And we'll talk about drop. Drop means all incoming traffic unless related to outgoing, which we know that's not today. do not even respond. As I already told you, the difference between drop and reject. Drop doesn't even respond with an ICMP error. I think with saving time, I'll skip talking about all this. And if you feel like you want to know more, you can pause this video and then look a lot at this. Now we have predefined zone settings, and then predefined zone settings are like settings, that's to say services that are allowed, that a zone is allowed. And then to view these predefined zone settings, you use the cat command and then you navigate to the zone file, and then the zone file is vertically marked with an XML extension. For instance, what we see here is available service settings in the public zone by default, and whereas that by default it allows SSH connection, and then it also allows DHCP version 6 client connection. You know how these services work is that when a service or a protocol is added to a zone settings, means it is allowed. But for instance, we don't have, let me say, telnet here. For instance, we don't have telnet service here, it means it's not accepted in the public zone. And then we have predefined zone services, which I'm saying to see a predefined zone service for a particular zone, use the command grep, and we know what grep is used for. You use grep-i and then you grep out service in a text file. Now talking about configuration, after here I'll be going straight to configuration level. We have three types that firewall can, three ways that firewall can be configured in the Red Hat Enterprise Zone. First of all, we have the GUI, and then the GUI we know is a powerful way of doing any configuration in Linux. I'll urge everyone who run any command in my trailer, you realize that first of all run the SU to get the sudo, that's to say the root, the super user power to run any command. And then with, excuse me to say, that was with terminal, not GUI. And then with the GUI, I think it's a way you have a physical, a graphical. It's the easiest way, but I don't like doing the easy way. It's like just Windows next finish, which is not powerful in Linux. Everything you do in the terminal, you can do it in the GUI. And we also have a way of editing Verox XML configuration files. This is really for advanced users. If there's enough time, I will go around it. Now let's kickstart with the terminal configuration. Now we are at this aspect where I was waiting for most. Basically, I like this configuration aspect because I love Linux configuration. Due to time, I'll be faster, so you have to be faster, or maybe you pause this video and watch it some way. First of all, before you do anything, you open your terminal and you right click on the desktop terminal. So when you open your terminal, the first thing you do is change to be a super user, which use the command su, and then you put your root password. After you're done with your root password, you make sure you start the firewall services, and we use the systemctl start, and then we type the service name firewall. This starts the firewall service, and after this we have to enable it. Now we have our service started and enabled, and then we can check, confirm the status using the systemctl status and then the service name. Now the command line utility for configuring firewall is firewall-cmd. To use this command, I know this is the first time most of you have seen this command, so we look for the help and then we add dash help, and then it shows us a whole bunch of things we can do over here. But with time factor, I won't be able to go through this all because I just have 3 or 2 minutes left, so I'll go straight with the configuration. First of all, to view all available zones, we use the command firewall -cmd and then dash list all, then dash zones. I'm used to this tab, so it keeps helping me. So we currently we have our work zone, our trusted zone, our public zone, and realize that our current network interface, which is the ENO, this interface is currently connected to the default, which is the public zone. You realize that we have default and active here. When a zone has no interface, it is not active, and then we can use a command to view all the active zones, which I will do later. Now, to get all assignable services that can be assigned to a zone, we use the command firewall -cmd and then dash. Then we use get -services. Now this gives us a whole bunch of services, and these are all services that DHCP version 6, key password, these all these are services that can be accessed on a network. Now I'll like to show about how to get the default zone if you don't know what the default zone is. So we use the command firewall. Assuming you just built a new server and then you don't know what the default zone is, you use fire. This syntax is only constant firewall -dd, and then you type get then default zone. It shows that our public zone is currently our default zone. And then let me see what else can we do. Now, for instance, let's add a rule. Let me say firewall cmd dash zone. Then I'll say the drop zone, and then I add dash a service, add service, and I say HTTP. It adds this service to the drop zone, and then we can confirm this by looking at firewall, oh gosh, dash dash list zone equals to drop. Okay, here is this zone is not, this is not required. Okay, let me list all zones and then we see something. All dash zones. So let's look for the drop zone T column. Realize that it has HTTP service added just because of what you did. Now when we restart our firewall dash reload, and then we re-get all our zones, and then we navigate to the drop zone. Whereas that the service is gone. This is because the firewall was that rule was added in a runtime zone. So right now, I'll teach you how to add, like, create your own customized firewall zone. First of all, we use the command syntax firewall cmd, and then after that we add a permanent, and then new zone space zone name. So I'll create a zone called gopher. So this is successful added, and then when we list we'll see it, but we'll make a reload to the firewall. We'll make a reload, and then we go to check our firewall zones, list all zones. Realize that gopher has been added, but it has no interface, nothing attached to it. It's just like same as the drop zone. Okay, so right now we've created a new zone called gopher. We can equally delete that zone, and then instead of the add we just use this. Instead of the new we use delete instead of this new, and then the zone is gone. So right now I'll go ahead to view default firewall settings, which is in a zone. So we use the command cat as I said earlier on in my presentation. Now let me say we navigate to user sr dot lib dot firewall dot zones, and then we can see that we have drop zone, trusted zone. For instance, let me choose public.xml, whereas that these are the default, this is the default setting, and then services that are allowed are so far DHCP version 6 client, and then SSH shell. So right now, to set a service to a zone, for instance our new gopher, which we do gopher has no service, so to set like a service to this new zone called gopher, we use the command succeeded. So I don't know why you are not okay. Now let's cut this file and see something. Okay, let's list all zones and see something. Where's gopher? Okay, now we can see that HTTP is part of gopher. I think something was delaying our task. But right now I'll teach you how to change like gopher zone to the default zone. By default, when you connect your computer to a network, the public zone is the default zone. So we can change this to a new zone, for instance gopher zone, by using the command firewall cmd dash dash set default zone to gopher, and then it has been succeeded. So far has been set as the default zone. So right now, any connection that comes in, for instance, if I say firewall cmd get default zone, whereas that Gopher is now the default zone. And then also what I can teach you is how to change interface and put, like for instance, we have our interface in the public zone. We can change it to go. First of all, we remove it from the public, and then we do this in a permanent configuration mode. So what we do is firewall cmd dash dash permanent dash dash remove interface ino. We have to take care of our interface name, then dash dash zone public. So this has been removed, and then we add it to the Gopher zone. So what just changed here is the remove and the add. Here we use add instead of remove. Make sure you check this, and then done. So right now we check Gopher again, and then we realize that list all zones. We realize that when you get to the public zone, there's no interface, but when you get to Gopher, an interface has been assigned to it. For instance, we have something called a special routing procedure in Red Hat. This routing procedure helps a lot. Okay, it helps in a way that, for instance, if you have a DHCP server on your network and then this DHCP server has an IP address of 10.0.0.1 with a subnet max of 8, I hope those who know subnetting will understand this. There's a way that you can, in fact, route all incoming requests to this DHCP server through a zone. For instance, we create a custom zone and allow only DHCP services. This will make our servers secure, meaning if someone is trying to telnet to our DHCP, it will bounce back. But like whenever a DHCP request is made to this service, it's, uh, is granted. So first of all, what we'll do is create a zone called DHCP, assign the DHCP version 6 service to it, and then we add a source. So first of all, I'll say firewall. So a zone called DHCP, and then I'll perform a restart in the firewall, and then I add DHCP version 6 to this, and then we have success now. So right now, when we look at firewall dash cmd list all zones, realize that our DHCP zone DHCP zone ABCD DB4E DHCP, our DHCP zone, this is taking low, but like it's supposed to have DHCP versus client, but it will come. So what we have to do now is put the routing rule, and then adding the routing rule means firewall.cmd dash dash permanent dash dash add source, and then we put the IP address of our DHCP server 10.0.0.1 with a subnet of 8, and then dash, then dash dash, then we select our zone. That's the source IP address, and then we make this come to the DHCP zone. That's all. So whenever this is coming through, a packet is coming through to this particular IP address on our network, it will come to the DHCP zone. It doesn't matter if this IP address belongs to a different zone. This is the zone it will route it through. I wish there was time. There is more to this, but I also like to talk about the graphical configuration. And then to open the graphical configuration, use the command firewall dash conf. This firewall dash conf and firewall dash config. Sorry, and I wait for it to load. So when it comes here, our zone, realize that our DHCP zone we created GHCP, and this is in runtime configuration. We can change this to permanent, and everything we do will remain in the permanent. And then we have some option here called lockdown. Lockdown is an instance whereby you set a lockdown time that the firewall rule doesn't apply. If you set it to 5 minutes, for 5 minutes the firewall won't work. So you should always make sure that this is not checked. I hope everyone watching this will like this, and then